Hello, this is video 3 for chapter 11. And this is where we left off, the distribution of lightning strikes globally. And you can clearly see the presence around the equator with all that heat, all that humidity, moisture off those warm tropical waters. Not a shocker that the places in the world with the most lightning strikes on the planet on each day are often in areas where you're near a warm body of water and you've got a lot of lifting mechanisms, often with convection and surface heating. So you could see almost literally where the world's tropical rainforest would be located in these hot spots where almost every day you have thunderstorms popping up globally. So just a nice map showing you the geography, and you could almost see where the world's deserts are, where you could see very drier air places like in North Africa and Southwest Asia and the middle of Australia. You could see the drier air masses literally can't produce the severe weather associated with thunderstorms and lightning. This is just a map showing you on a given day how temporal patterns work for lightning. And generally we could see over land that most of the lightning occurs during the daylight hours when you've got a lot of convectional heating. That surface heating is what really stabilizes. But it's very interesting in Tornado Alley. It tells you that a lot of the lightning strikes are at nighttime when the sun is setting, because remember, we don't need surface heating. We have frontal lifting. And frontal lifting can occur without necessarily needing the sun to be out, because as long as we have cold air driving into maritime tropical air, it doesn't really matter what time of day. And that's why we can get thunderstorms and severe weather at all times of day in the Midwest where we live. Tornadoes are just simply measured by massive changes in air pressure over short distances, and that's what gives them the massive ability to produce strong winds. And where they form, the geography of where they form is obviously, we've got to find cold fronts and supercell thunderstorms traveling out in front of them. We often can find tornadoes embedded within hurricanes as well. But from our perspective, and for this chapter, we often talk about their occurrence in Tornado Alley in the Midwest and how they occur along cold fronts. And that's where our focus will be from here on tornadoes. What we got to have is a rotating thunderstorm, which we call a mesocyclone. And we need a thunderstorm spinning, and we've talked about that in previous sections of this chapter. Is we've got to get wind shear to get air rolling, air coming in from different altitudes at different directions, and that gets us to get a ball of air beginning to roll. And as a thunderstorm begins to form, if it sucks up one of these areas where we get air rolling due to wind shear, as that air is rotating horizontally, the updrafts begin to pull up that horizontally rolling air into a vertical column, and that's what gets the whole thunderstorm to begin to sit and spin. And so once we identify wind shear, many severe storm chasers know the conditions are getting favorable as thunderstorms begin to fire up. If they begin to roll over these rotating columns of air, horizontal rotating columns, they know these thunderstorms will suck them up with the updrafts into a vertical column, and that's when the whole thunderstorm will begin to spin like a tornado. And this is what a supercell looks like. When you travel into a supercell from the east, we see there's almost a very specific pattern of weather as you go from east and move west, from light rain to heavy rain, and then we go into the large hailstones. And then you might start to see a wall cloud identifying where you're starting to see that heavy updrafts on the backside of supercells. That's where we often find those heavy updrafts, is where we find on the backside of the thunderstorm, after all of the heavy rain, when you think you've gotten through the thunderstorm, is actually where you will actually find the tornado lurking, is when you actually think you actually have gotten through the storm. In fact, you might even see the sun shining in the background. And that's why when you watch a lot of tornado videos on YouTube, you might actually see the sun shining in the background, because the tornadoes are often on the southwest corner of many thunderstorms, or on the backside of them. So just when you've driven through all of the heavy rain, maybe even hail, you'll see the cloud lowering and maybe even the winds getting calm. That's often where we often see the tornadoes. Just when you think you've gotten through it and you're into the safest air, you're actually into the most dangerous air. So I would actually advise you to go, how are tornadoes produced? And you could find some great searches on YouTube and videos, and you could see this whole process animated. So I'm going to go through these slides here, and I want to talk about the timing and location of tornadoes. And this is the extra credit assignment that I often assign, called Mapping Tornado Alley. And this is just a fascinating video, and I'm going to kind of go through some slides here. When you go through here, you could see when we look at tornado frequency around the world, there's no doubt about why tornadoes are associated with the United States, and in particular the Great Plains states. You could literally see Tornado Alley here in the Midwest, and there are tornadoes occurring all over the world, but in terms of frequency, there's something special that has to come together to produce tornadoes, and many of the ingredients that build tornadoes, most of the other continents can't put all together. And I'll kind of summarize those here together of why is North America so special for producing such a high frequency of tornadoes. And it has everything to do with this map. To produce a high frequency of tornadoes, you got to first have to have air masses that come together from multiple directions. And when you look at where the highest frequency of tornadoes are in the world, there's no doubt that Oklahoma here in the middle of Tornado Alley, you could literally see the boundary of Tornado Alley here, that you got to have air masses that could come together. And first of all, we've got them. We've got maritime tropical air, we've got continental polar air, and we've even gotten continental tropical air. And they can all converge very nicely together, and the jet stream can mix them all nicely together in this area. Due to the flat nature of our terrain, the air masses very easily are allowed to move across this flat-lying ground. So it's not just the presence of the air masses. We have a jet stream that can pull these winds together, and they very easily can march into one another due to the flat-lying geography. And that's why we have some, in Tornado Alley, we have the highest frequency of tornadoes in the world in this area. There's a very good map here showing you that the frequency of tornadoes is most active from April through August, through spring and the early summer months, and this is when the maritime tropical air is at its most active in its ability to march to the north into Tornado Alley and interact with that continental polar air. So there definitely is a seasonal pattern to this, but in my exercise, I actually have you mapping when tornadoes occur by month, and I think you'll be fascinated to see where tornadoes occur by month very much does change by season. And so if you live in Minnesota, or you live in Missouri, or you live in Texas, what month you're likely to see tornadoes does vary because of the movement of the jet stream. And it's just a great exercise for you to go through, and I think I often offer it as an optional extra credit. So here's a nice map showing you some of that, the geography of by month of when tornadoes occur. And you begin to see in Tornado Alley by month how that does vary. And I'm going to skip over this fairly quickly because I do have an exercise on this. This is a nice map showing you the frequency of tornadoes over time. And as you could see over time from the 1950s up into the modern era, how the trend has been upward. And this very much could be due to a variety of reasons, but a lot of people do believe the reasons why the tornado observations are observing more tornadoes being observed and monitored is the technology has gotten so better that we have more cameras and more radar, and we have more satellite imagery to help us find them and identify them, that this trend upwards could be just due to the rise of technology. How we identify tornadoes and track damage and debris is on the F scale, and on my exercise you could see and read the chart here very nicely how we identify with the Fujita scale how I think it was Dr. Ted Fujita came up in a controlled laboratory of monitoring how winds did damage to property. And in my extra credit activity, Mapping Tornado Alley, I really have you looking at the F4 and the F5s, which are your much more devastating tornadoes that do severe damage to property and cause more deaths. And I really have you looking in, and it's very important to note that they're not the most frequent. By far, the F0s to F3s are way more frequent, but the F4 and F5s are the ones that do severe, much more damage. And what I'm going to, you could actually see sometimes, you could see, for example, here, tornado tracks on this satellite image. What I'm going to do here is I'm going to have, and I'm going to stop it here because I'm at that 10-minute mark again, and I've gotten through, I can't say, if you're a visual learner, how tornadoes occur with a YouTube search could be very helpful for you to visualize. What I've been talking about is what causes a thunderstorm to rotate and to drop a funnel. I don't think you could beat what you could find on YouTube if you're that kind of visual learner. And also going through my mapping the tornado lab, or Mapping Tornado Alley optional extra credit, I really go through some interesting geography of what time of year do tornadoes occur, what time of day, and you really can begin to understand what are called storm tracks, which have been introduced. Is that, you know, the jet stream is up over the northern states in summer. The jet stream is obviously over the Midwest and Tornado Alley in spring, and often during the winter months is over the jet stream during the winter months. And as the jet stream moves north and south, that's what brings these air masses together and why there is a geography to this whole thing. So I would strongly, if you're interested in these subjects, really using my interactive map, using a GIS mapping software, you answer some basic questions and it helps give you some understanding of sort of this cycle pattern to understanding tornadoes and seasonal patterns. But I'm going to go ahead and stop it there. I know I'm getting very close. We talk about watches and warnings, and you could read about those. And that's the end of chapter 11. And I want to cut this. I did go 2 minutes longer than I wanted, and but I do hope it helped you understand the severe weather chapter, and I'll lean on you to use outside resources as you see fit to understand the topics better.